recording now. Here we go. Okay, so if it's just for copper on its own, and if you have to work out the relative atomic mass, it's quite straightforward because all you do is you look at the periodic table and you look for the bottom number. So you go there and you find copper, you find it over here, and then you see the bottom number. The bottom number is 64. The relative atomic mass of copper is 64. So in that case, the answer or the thing you would write down there is 64. If somebody said just oxygen on its own, nothing else, if you wanted the relative atomic mass, you would go to the periodic table and you would look for oxygen. And the relative atomic mass is 16. Cool. So that's the relative atomic mass. So for elements, it's very straightforward because all you do is you look at the periodic table and you just record the value that's at the bottom in the little blocky. Ooh, any questions so far?
No, sir.
Yeah. So when we say relative atomic mass, all we're basically saying is that these molecules have a mass, and relative to each other, some elements are heavier than others. So it makes sense that copper is heavier than oxygen because it has more protons, neutrons, and electrons. Also, it's a heavier element. And that's what we mean by relative atomic mass. They just, they have mass, and their mass is relative to they're relative to one another. Also, copper relative to oxygen has a greater mass. And we're just thinking of molecules here. We're not really thinking of how many molecules. We're just thinking of as a single molecule. Cool. Then you can start getting more complicating things, and you can start talking about molecular mass. And now when you hear molecular mass, you think molecule. So the top one that we did was just atomic mass. So over here, this first example here, this was just atomic mass. Now we're going to think of molecular mass. So now when I say O2, I'm not thinking of an oxygen atom. I'm thinking of an oxygen molecule. And in this case, oxygen's molecule, it's 2 oxygen atoms. So based on its, if one atom is 16, how much would 2 atoms be is the question.
Wouldn't it be 8?
You're almost on the right track. You halved it, but you shouldn't halve it. You should do the other way around.
32.
Double it.
Correct. Yeah, so we're going to double it. So it becomes 2 times 16, which is 32. Because remember that an oxygen molecule is just 2 oxygen atoms bonded together. So if one oxygen atom has a mass of 16, then it means that 2 oxygen atoms have a mass of 32. We just add them together. Cool. So let's just add to our list over here. If we have just a hydrogen atom on its own, hydrogen's relative atomic mass would just be 1. So if you look at the periodic table, hydrogen's here, hydrogen is just 1. So then you can start looking at slightly more complicated molecules, and you can play around with it. Now we can look at, let's say, H2O, so water. So we're looking for the MR of water. In other words, if I added up the masses of all the individual atoms, what would the total mass of a water molecule be? So just think about that quickly for a second. How would you do it? And then somebody give me an answer. Would anyone like to give it? It's 2 hydrogens, correct? So you would have 2 times 1, and then you would add it to 1 times 16, and that would give you 18. So the oxygen would count for 16, and the 2 hydrogens on their own would count for 1 each. So your total mass of the combination of 2 hydrogens and 1 oxygen would be 18. Cool. Does anyone have any questions? Does it make sense so far? Is there anything that's a bit confusing or that you would like me to go over again?
No, sir.
You good? Inesh, you good?
Oh, good, sir.
Good. And then Mia, are you okay?
Yes, sir.
Good, good. Okay, so we can just carry on with this. We can just keep doing a couple of examples. So if you have a pen and paper out quickly, you can write this down. What I'll do is I'll quickly write the I'll give you the molecule, and then what I'll do is I'll put the periodic table on in the background, and then what you can do is just sit with a piece of paper quickly and work out the relative molecular mass. Cool. So we're going to look at sulfuric acid H2SO4. So 2 hydrogens, 1 sulfur, and 4 oxygens. And then you have to calculate the MR. So I'll give you a few minutes, and then all I'll do is I'll put the periodic table there in the background for you. Can everyone see the periodic table?
Yes, sir.
Yeah, good. So just have a look at that. And then just for the next few lessons, for the next few, if you can find a printout somewhere, look at an old past paper or past exam, you'll find a periodic table there somewhere. So look in your file, you'll definitely find a periodic table somewhere. Cool, but for now, just use the one on the screen. Cool, and then the question is H2SO4. So you're looking for this one at the bottom here. So we're looking for H2SO4. Participants, hydrogen, we want sulfur, and we want oxygen. Sorry, I put the participants away. I can't see. Let me just quickly get the thing back. Just give a thumbs up. Yeah, Inesh is done. Just I missed the thumbs up. If you're done, just give a quick thumbs up, then I can see. Cool, Laura's done. Mia, you good? You need a little bit of time? Mia's good. Okay, excellent. So who would like to talk me through it? What calculation do we need to do? Inesh, Dr. Anybody, doesn't really matter.
I'm not 100% sure, sir. So
Cool. So what would you have
wanna do
done?
it?
No problem, but what would you have done? So talk me through it quickly. What was your thinking?
So we already know from the previous one, hydrogen would be 2 times 1.
Exactly, yes, because you have 2 hydrogens and they each have a mass of 1. That's correct. What else?
And then we know sulfur
Go back to the
is
periodic
32.
table. Correct. So sulfur on the periodic table, the relative atomic mass is 32. And then what are you going to do with the oxygen?
This was what I was not sure was really. So
Okay,
do we
so-
say
so let-
16 times
Yes.
4 and then
Exactly. 4 times 16, because it's like what we talked about last week during just counting elements inside molecules. We've just identified the fact that there's 4 oxygen atoms inside the molecule. And if each oxygen atom has a mass of 16, it means I have 4 times 16 total oxygen. Cool. And then you just put that in your calculator. Make sure you put the brackets and everything in the right place. And then you add all that up. So I don't have an answer with me. Can anyone just shout it out quickly?
98.
98. Does that sound right to everybody?
yes, sir.
Good. Excellent. So that's basically as straightforward as it can be. So the only time it can be confusing is when you have these things with brackets. So I'll show you an example where a formula has brackets inside it. And I purposely didn't do this with the core students because it gets very confusing. But if we look at something like this, copper nitrate, so the NO3, and then brackets 2. Oopsie. So this is copper nitrate, copper 2. And the bracket there is basically telling you that you have 2 of everything inside the bracket. So that you could rewrite this if you wanted to, and you could multiply it out like you, whoopsie. You could multiply it out like you do in maths, and you could write it like this. It's actually telling you that there's 2 of everything that's inside the bracket. So it would look like this. So you have 1 copper, 2 nitrogens, and 6 oxygens. So if you were going to summarize it, you could say that this is actually NO3. So does everyone understand more or less? Oh, no, not 3, 6. Does everyone understand more or less what that bracket is saying?
Yes.
Yes, sir.
Yeah, so the bracket is basically telling you that whatever number comes outside the bracket is that many of everything inside the bracket. Also, I'll give you another example where it's not a 2. Let's do Al, aluminium, Al2, hang on. Al2, SO4 bracket. That's a small. There we go. So that 3 over there is telling you that there's 3 of everything inside the bracket. So we can rewrite this. We can say this is aluminium SO4. And then we can copy and paste that. So we can just say this is the same thing 3 times. And the 2, sorry, for the aluminium, that doesn't disappear. That's still there. Cool. So then you can count the number of atoms again, and you can say that it's 2 aluminiums. You can put the sulfurs together. You can say there's 3 sulfurs, and then there's 4 times 3 oxygens, which is 12 oxygens. So that's basically what you would do with the brackets. You just multiply everything out, and then you can find the formula. And then it's exactly the same. All you do is you look at the periodic table, you look for the relative atomic mass, and then you just multiply by the numbers in the brackets. So quickly write these 2 down, copper nitrate and aluminium sulfate, and then work out the molecular mass. So work out the molecular mass for aluminium sulfate and copper nitrate. Well, and if you get done, just give me a thumbs up. Then what I'll do is I'll go back to the periodic table if you're done writing that down. Just give me a thumbs up, then I'll go to the periodic table for you. Good. Mia, you good? So just write down the formula. Yeah,
Sorry,
talk to me.
give me a second.
No problem. Take your time. So
Can I write down?
Yeah, just write down the formula. That's the most important. So you need the formula to be able to answer the question. So as long as you have the formula, then you just need the periodic table. Cool, so you're good. There you go. So here's the periodic table. So you've got to look for copper, you've got to look for nitrogen, and you've got to look at copper, nitrogen, oxygen, and then for the next one, aluminium, sulfur, oxygen. So you've got to find oxygen. You're going to realize that it's going to be the same elements always. Oxygen is going to be very important always. Sulfur will appear quite often. Carbon will appear quite often. Nitrogen will appear quite often. There's copper down here. And then aluminium is in group 3. It's over here on its own. Participants. Let's go find the other screen share quickly. Oh, where's my mouse? Oh, excuse me. Cool, Dodger's done. Laura's done, good. Inesh is done, Mia's good, excellent. So we can go back then and have a look. So just quickly walk me through copper nitrate. How do we go about that? Mia, you can try this one. You haven't done one yet.
I said that the copper was 64.
Correct, so same as always.
And then there's 2 nitrogens, so it's 14 times 2.
Correct.
And then there's 6 oxygens, so 16 times 6.
Correct, 100%. And then whatever value that is, I don't have a calculator, but you can just tell me if you calculated it.
188.
188. Everyone happy with that? Sorry, I can't see the thumbs up. Just shout out. You can just say yes.
Yes.
Good, good.
Yes, sir.
Cool. So everyone's happy with 188. So it's quite a big number. And that makes sense because it's made up of a lot of atoms. So obviously the more atoms something is made up of, the bigger its mass is going to be. Cool. And then aluminium sulfate, who wants to talk me through that? Inesh or Laura?
So there's 2 aluminiums.
Cool.
So 2 times 27.
Perfect.
And then there's 3 sulfur. So
Correct.
3 times 32. And there's 12 oxygens. So 12 times 16.
12 times 16. Perfect. And that gives you a really big number, I'm assuming.
342.
That makes sense. I've used aluminium sulfate before. I've seen that number. So that makes sense to me. Okay, so you guys get the basic idea. You get the concept. You use your periodic table. You count the number of atoms, and then you multiply them by the mass of each individual atom. So what you can do for practice, I'm not going to give you like a worksheet or anything. What I'm going to show you is that you can use the worksheet that you already have. So I'll show you quickly. If you go to your previous worksheets, this one over here. Yep. So don't worry about the balancing. Forget about the balancing. Take away the balancing numbers. And then all you can do is you can just look at chemicals and play around with it and then work out the molecular masses. So if you, sorry, I just need to zoom in here quickly. Take an example. You can choose a chemical. Here we go, iron hydroxide. You can choose that. And then you can just work out its molecular mass. So Mr is equal to, and then you add up all the numbers and do whatever you have to do. And then you can just practice. You can do as many or as few as you want. And as soon as you feel like you have the concepts under control, then you can just, you don't have to do any more if you don't have to. Well, but just practice. Do about 5 to 10 just for fun. And choose difficult ones. Choose ones where there's big numbers. So choose one like, I don't know, here's glucose, I think. No, there's no glucose. Here's nonane. I don't know, it's some really big alkane. So choose something like that. Choose ones with brackets. So lead hydroxide, there's a bracket. That's a nice one. There's aluminium sulfate we just saw. What else? Let's see if there's any other ones that look difficult. There's glucose. Sorry, now they're in the red blocks. That's glucose. So that's photosynthesis, that equation. There's sodium hydroxide. Yeah, so just play around with it. That's all you have to do. Just do as many as you can until you get the hang of it. Cool. Any questions?
No, sir.
Good. Yeah. So just do that, and then try to find yourself a periodic table. Unfortunately, I'm not in Volfus at the moment, so I can't print it out for you and leave it at the reception. But just look at one of your old past papers. There's definitely a periodic table somewhere on one of your past papers, or in your textbook or something somewhere.
Yes, sir.
Cool, guys. Be good. Behave. I'll see you guys tomorrow.
Bye, sir.
Bye, guys.
Bye, sir.
Yes,
Bye.
sir. Thank you.
You're welcome.